Welcome everyone to another video episode for General Chemistry 1 representing compounds by using types of chemical formulas. So for activity 1, we will complete this table by pairing cut ions on the first column and the anions on the first row here. So we go to the first example. We pair H plus 1 with OH minus 1. So the two of them will be paired, can be written as HOH or H2O. Next, we have hydrogen ion paired with phosphate ion. So that will become, this 3 will go to the hydrogen H3, and then PO4 times 1 will remain as PO4. So the correct formula is H3PO4. Next is O2 minus 2. This is peroxide. And we pair it with hydrogen ion. So we write H, but we need to cross over this 2 to hydrogen, and then O2. There is a plus 1 here, but it doesn't affect the formula. So the correct formula is H2O2, or this is hydrogen peroxide. The next is hydrogen ion and chloride ion. Both have the same oxidation numbers, so just copy HCl or hydrogen chloride. Remember, this is a review of the past video lesson, so I will not be very detailed about this, okay? So the next is copper. It is the same thing. So you pair it, and then all of it here, you pair it. The same with ammonium ion. So you only need to do number 4 to 8 because 1, 2, and 3, the answers are already given. Then let's go to the next. Types of chemical formula. So the first one is molecular formula. It gives you the actual number of atoms of each element in a compound with the help of the subscript. For example, glucose is C6H12O6. So we will do activity number 2. Write my molecular formula. Methane, butane, heptane, and octane are hydrocarbons. That means these are compounds containing hydrogen and carbon only. Sucrose is a disaccharide or a double sugar. This is also our common table sugar. So, for methane, the molecular formula is CH4. For butane, C4H10. This was taken up in your junior high school, so again, this is just a review to you. And then we have heptane and octane. Remember that we have the prefixes. For 5, it's penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Okay, so just write the molecular formula. Then let's go to empirical formula. It tells the ratio of the elements present in a compound. The subscripts tell how many atoms are there that leads to a whole number ratio. For example, the molecular formula of glucose is C6H12O6. One molecule of glucose contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Since empirical formula is known as the simplest formula, you must find the common factor of the subscript to get our answer. So, for glucose, C6H12O6. The common factor is, right, 6. So we divide all the subscript with 6. So carbon will become 1, 6 divided by 6. Hydrogen will become 2, 12 divided by 6. And oxygen will become 1, 6 divided by 6. But remember, there's no need to write 1 in the formula because it is understood that if there are no subscript, the number of atom is 1. Okay? Now, note, if the compound has no common factor, the molecular and empirical formula can be the same. Example for that is water. Water has a formula of H2O. And look, there is no more common factor to divide the subscript. That means the empirical formula is the same with the molecular formula. Okay? Then activity number 3. What's my empirical formula? So, the same table we had above. So we have the compound, the molecular formula, and empirical formula. We just added one column for empirical formula. Okay, so methane is CH4. There is no common factor. So the empirical formula is also CH4. For butane, C4H10, is there a common factor? Yes, you're right. There it's number 2. So we divide the subscript with 2. So that would be C4, or 4 divided by 2 is 2, and 10 divided by 2 is 5. So the empirical formula for butane is C2H5 because there is no more common factor that will divide this subscript. So that would be the final empirical formula for butane. Now do heptane, octane, and sucrose. And you put your answers here. We could also calculate empirical formula by compound from percent composition. Since percentage is given, we can assume that the compound is equal to 100 grams. So we have a sample problem here. What is the empirical formula of a substance that is 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen by mass? So as we had before, when we solve problems, we need to follow steps. The first step is to write the given. So we assume 100 grams of the substance. And then the mass of carbon is 40% of 100 grams, which is equal to 40.0 grams. How did we get 40.0 grams? 40% divided by 100 to convert this percentage to decimal and to remove the percentage sign. So 40 divided by 100 is equal to 0.4 times 100. That would be equal to 40. We just add a decimal and a 0 to show the decimal point. Mass of hydrogen 6.7% divide this by 100, it will become 0.067 times 100 is equal to 6.7 grams. Mass of oxygen is 53.3% divided by 100, it becomes 0.533 times 100 is equal to 53.3 grams. Add this all, it will become 100 grams. Okay, then what is required? What is the empirical formula? The formula that we will use here, class, is the mole. Mole is equal to the mass times the molar mass. Okay, solution. Convert these masses into mole using atomic mass of carbon, hydrogen, and oxygen. Check your periodic table for the atomic weight or atomic mass of the element. Now, so the atomic mass from the periodic table is carbon is equal to 12.01 AMU. Hydrogen is equal to 1.01 AMU. And oxygen is equal to 15.99 AMU. AMU is atomic mass unit. We convert atomic mass or the atomic weight into a molar mass by just changing the unit. So, we carbon has an atomic mass of 12.01 AMU. We rounded it off to 12 for convenience and changed AMU to gram per mole. So the molar mass of carbon is 12.0 gram per mole. MOL, mole, is just a shortcut or abbreviation for MOLE, mole. Okay? Hydrogen is equal to 1.01 AMU. We rounded off to 1.0 gram per mole and change the AMU to gram per mole. Oxygen is 15.99 AMU. We rounded it off to 16 and changed AMU to gram per mole. So these are the molar mass of these elements. Now, the molar mass can be also written like this. Carbon is equal to 12.0 grams in 1 mole or per mole, or carbon is equal to, in 1 mole of carbon, there are 12 grams. The same with hydrogen. In 1 gram, there's 1 gram of hydrogen in 1 mole of hydrogen. Or in 1 mole of hydrogen, there is 1.0 gram. It's the same with oxygen. So you just decide which of these two to use so that you can cancel out the required unit. Okay, so here we need to cancel grams because we need the mole because we will use mole. Okay, now, so between these two, this one here, the one with the green highlight, is used because when the gram is in the numerator, the other gram to cancel it out should be in the denominator so that these two will cancel out. Okay, so here for carbon, 40 times 1 mole over 12.0 grams cancelled. What is left is mole. 40.0 divided by 12.0 is 3.33 mole of carbon. It's the same with hydrogen. 6.7 gram times 1 mole per 1 gram. Gram and gram cancelled. What is, and the answer is 6.70 mole of H. Then for oxygen, 53.3 grams times 1 mole of O over 16.0 grams of oxygen. Cancel grams of oxygen. Cancel grams of oxygen. What is left is small. 53.3 divided by 16 is 3.33 mole of carbon. So, what will we do with this? Determine which mole has the smallest value and divide the mole values you calculated in step 2 by this value. So what is the lowest number of moles here? It is 3.33 for carbon and oxygen. Okay, now let's go to the second step. So we have for carbon 3.33 mole carbon divided by the lowest value here. The smallest value is 3.3. The answer is 1 mole of carbon. And next, for hydrogen, 6.6 mole hydrogen divided by 3.3 is equal to 2 moles of hydrogen. For oxygen, we have 3.33 mole of oxygen divided by 3.33 is equal to 1 mole of oxygen. So, that is your answer now. The empirical formula of the compound is C1H2O1. Okay? C1H2O1 or simply CH2O. You do not need to write the number 1 because it is already assumed as 1 if there is no subscript. Note, if any of your mole ratio are not yet in whole number, multiply all the subscript by the smallest possible factor that would result to a whole number mass ratio for all elements. Okay, next, structural formula. It displays the arrangement of how atoms are bonded. It shows how atoms are bonded to one another, such as single, double, triple covalent bonds. Covalent bonds are shown using lines. The number of dashes show the bond as single, double, and triple covalent bond. Example, we have ethane, C2H6. So if there are 2 carbon, you also write 2 carbon. And then 6 hydrogen. There should also be 6 hydrogen. Remember that carbon bonding follows the octet rule. So there are 4 bonds around the carbon atom. Okay? So every carbon atom contains 4 bonds, including the one that they are sharing. So if we have to count, we have 2 carbon and we have 1, 2, 3, 4, 5, 6 hydrogen. So that is what we call the structural formula. Okay, let's go to activity number 4. Build my structure. Draw the structural formula of the following compound. Propane. So we have here already the molecular formula C3H8. So we have 3 carbons, 1, 2, 3, and there are 8 hydrogens. So remember I mentioned that there are 4 bonds around the carbon atom. So we have 1 on the first carbon atom, we have 1 and 2. You put 1 here on top and another here below. 1, 2 for the second carbon atom, 1 here on top, 1 below. For the last carbon atom, we have 1, 2. We put 1 on top and 1 below. So for each of this bond, there is a corresponding H. Okay, so we have here 1, 2, 3, 4, 5, 6, 7, 8. So that is propane. And methane, we have it here, the structural formula. For butane, here, butane has 4 carbon atoms, 1, 2, 3, 4, and it has 10 hydrogen atoms. So remember, for every carbon atom, there are 4 bonds around it. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, and then just write H at the end of each bond. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 hydrogen atoms bonded to 4 carbon atoms. Okay, that is the structural formula for butane. So you have to do heptane, octane, and sucrose. the last here is the condensed structural formula. How do we do uh, condensed structural formula? It is a way of writing organic structure in a line of text. It shows all atoms, but it does not include vertical bonds and most of all of the horizontal single bonds. So for example, ethanol C2H6. Ethanol is an alcohol which has an OH. So this is ethane, and then H was removed or exchanged with an OH. So that is ethanol. So this is C2H6, C2H5OH. Okay, C2H5OH. Here we have C2H5OH. So this is the structural formula. The condensed is you just have to write C, then count the number of H, 3, and then the next carbon we have 2, you just write it, CH2, and then add this functional group of OH at the end. CH3, CH2, and we have the OH. Next example, we have 1, 2, 3, 4. Okay, and this is 5 carbon, but this is not pentane. This is butane with 1 branch. Okay, so how to do this? So you just have to, the same as the example, the first example. So you just have to write C and then count the bonded atom around it. So 3 hydrogen. For the next, we have CH2 and then CH, CH, and then you just put a bond here because it is a branch, and then count this CH3. And then the last one is CH3. That is the condensed formula. So that means you only have to follow the structural formula, but you are writing it condensed in condensed form or as shortened or uh, without writing the bonds, the lines. Okay, it is the same class. Now you just follow this, just write the number of atoms that is bonded, and then just condense it. CH3, CH2, CH3, CH2, CH, and then we have CH3, and then this one is CH3. Okay, so this is your final table for your answer sheet. Okay, so all the other tables there uh, is added here. Now this is the complete one. So you have the molecular formula, the empirical formula, the structural formula, and the condensed structural formula. So all you need to answer are these three remaining numbers, 3, 4, and 5. You do it here. Okay, so I hope that you understand our lesson and hope to see you again on our next video episode. So have a good day. Thank you for watching and please subscribe.